Hello and welcome to this short video introducing Assertivity's work management framework. This is our interpretation of the processes an organization needs to have in place to oversee the safe, effective and efficient execution of maintenance. Naturally, your organization may have its own version, and we are happy to accept that there is not one right way to construct such a framework. The outcomes, however, should be consistent, which means that each responsibility we discuss should be covered somewhere in your framework. We would encourage you to examine each responsibility to ensure that it is covered and that the individuals involved both know what they need to do and have the appropriate competency and resources to do it. Our framework is arranged in a cycle consisting of 5 core processes. We begin by identifying the work required, since we can't do any work unless we know that it is required. We then plan it so that we know how we are going to do it and what resources are required. The work can then be scheduled, which means determining who will do it, when, and sometimes where. The work can then be executed, and finally signed off as complete, feeding back any improvement opportunities into our cycle. In addition to these basic processes, we recognize 13 sub-processes that are required. We'll talk about these next, starting with those relevant to identifying work. The first step in identifying work is to establish all of the tasks that are competing for maintenance resources. This is done primarily by interrogating the organization's maintenance information systems, but often also involves consulting other sources, such as vibration analysis databases, project engineers, and structural engineers, all of whom may have special requirements. The set of tasks will include both preventive and corrective maintenance tasks as determined by the organization's equipment strategy development methodology, for example, reliability-centered maintenance. It may also include modifications to the equipment. The set of tasks will often include poorly defined work, duplicates or inappropriate tasks that do not align with the defined roles for maintenance personnel or the defined maintenance strategies for equipment. For example, a work request may be raised to fix a minor leak on a water pump that is on a run-to-failure strategy. In order to prevent these tasks consuming resources, we conduct a work screening process to filter them out and provide feedback to the originator. Invariably, the resources required to complete the tasking will exceed the resources available on occasions, even after screening. Consequently, our work identification processes finish with a prioritization step that ensures each task is dealt with in an appropriate time frame that is consistent with the risk to the business. This is often achieved through simple business rules, but is fundamentally a risk assessment process. At this point, we have a set of valid prioritized maintenance tasks, but we don't necessarily know how to accomplish them, and we probably don't have the resources available in the organization. Working out these details is the role of our planning processes. Planning work is perhaps the most critical part of the whole work management cycle, since it is where there is the most opportunity to control the risks associated with maintenance. These risks include safety risks to maintainers or to bystanders that might arise from maintenance execution, for example, from falling objects, chemical exposure, pressurized equipment hazards, and many more. They also include maintenance effectiveness risks from incorrect maintenance procedures such as assembling components backwards. These could cause equipment failure in service and subsequent safety or production losses. They also include maintenance efficiency risks that increase the cost of maintenance due to delays or rework associated with incorrect or missing parts, tools, or equipment when these issues are found during the job. It's worth noting also that there are many hidden risks in maintenance. For example, leaving a part off the materials list for a job might seem like an inconvenience, causing an extra trip to store, but it breaks the concentration of the maintainer and can significantly increase the risk of a maintenance error, which may be associated with safety or production loss consequences. The best way to manage all of these risks is to thoroughly plan the work ahead of time and to accurately document the task sequence, hazards, materials, labor tools, and any other relevant information in a well-structured work pack that the maintainers can access at the job site. We call the preparation of this work pack job planning. Once the job has been planned, the resources need to be procured. Placing the orders is usually the job of the planner, since there are long lead times for many resources and it is not worth passing the job to the scheduler until the delivery times are known. Of course, this step involves working closely with procurement and inventory management staff to ensure that the right parts are available at the right time without incurring unnecessary costs for holding them in the store. Once the work pack has been completed and the parts ordered, the job should be passed to the scheduler to manage. The scheduler will begin with a long-term view of the maintenance department's workload against their capacity and will move jobs forward or backwards in accordance with their priority in order to balance the two. The scheduler may also seek out additional resources from other departments or from external suppliers to deal with unavoidable peaks. There are many options as long as the organisation has a reasonable forward log management process to provide enough time to adjust to workload variations. As the execution date for the work approaches, the scheduler will prepare a detailed schedule of the work to be completed in the scheduling period, often a week. In preparing this schedule, the scheduler needs to review all of the job plans and make any last-minute adjustments for current equipment condition and for interactions between jobs. An example might be a damaged walkway that requires an alternative, longer maintenance route through a plant. Another would be the need to avoid scheduling one work group working above another where there was a risk of falling objects. A third would be adjusting the work sequence to allow a single hire crane to be shared between multiple jobs. Taking all of these considerations into mind, the scheduler prepares a comprehensive program of work to pass to the maintenance supervisors for execution. In preparing the scheduler needs to maintain visibility of backlog tasks, jobs scheduled for completion previously but not done. Backlog can be a useful way of managing peaks and troughs in maintenance work, but it can also be a major source of risk if not well managed. Another important topic is the use of standing work orders. These are used to track costs against low criticality tasks such as workshop cleanup. They are not strictly required, but can present a useful way of capturing basic data with minimal effort if used well. We move on to execution next, which is obviously where the maintenance work actually gets done. This is the realm of the maintenance supervisor, who needs to act as a manager and leader rather than a technical expert. This means that they maintain visibility of the risk associated with all tasks under their control and provide supervision in accordance with that risk. This might include risks arising from infrequent tasks, inexperienced crews, complex tasks, critical tasks, or other sources. In addition to ensuring the quality of the work, the supervisor needs to oversee a miniature work management cycle of their own. This is necessary to support changes to the plans and schedules arising from both breakdown work, which are high-priority corrective tasks that arise during the scheduling period, and issues such as staff illness or absences, jobs overrunning, incorrect parts delivered from store, and many more. The breakdown loop in particular is a serious issue since there's a strong tendency to drop everything when production stops and to rush to start work on the problem. But this can lead to poor safety and quality outcomes. It is always important to conduct enough planning and scheduling to ensure safety and effectiveness, even if it does cause a temporary efficiency hit. The last stage of our work management cycle is completion. This step is often seen by maintainers as an unimportant administrative burden, but it is critically important to the organisation's ongoing improvement and therefore success. Tasks include returning unused items or failed repairable items to store, cleaning up the work site, updating the maintenance information system with the details of the failure, work done and resources used, and providing feedback to the planners and schedulers on any issues encountered during the conduct of the task. It is also critical that the maintenance department has processes for analysing performance and conducting continuous improvement. This will include simple improvements, such as adding additional materials or job steps to a work pack, more complex technical changes, such as modifying the frequency of inspection tasks or changing operating profiles, and even potential changes to the configuration of the equipment or the organisation's management systems. The planners and schedulers are often best placed to see patterns in equipment performance that might drive such changes, such as increasing frequency of corrective tasks arising from inspections or increasing frequency of failures, and therefore have a critical role to play in ongoing organisational improvement. So there we have it, Assetivity's work management framework consisting of 5 core and 13 detailed processes. In our opinion, every maintenance organisation should have at least one documented process covering the equivalent topics. There is, of course, much more to know about each topic, but we hope this introduction has given you some insight into good practice in work management and perhaps some ideas about potential improvements in your organisation. Thanks for watching. We hope you've enjoyed it. For more detail on anything in this video, please visit Assetivity's website or give us a call using the details shown on the screen.